I think the most important thing is to look us in the eyes and tell us the truth. It is a run for the market right now, and it will not happen unless we want it to be.
All right, Professor Daub, thank you very much for taking your time.
Thank you for having me.
Yeah, and allowing me to park the battery expedition vehicle here at IWB directly in the testing and research hall. And yeah, we want to talk about our European battery ecosystem and how to leverage research and our knowledge all the way to industry. I think we have still a little way ahead of us. And this is what I want to talk about with you today. But before we jump into today's discussion, I want to understand how you found into the field of battery research.
That actually happened by coincidence. So I am an electrical engineer by training, and I did my PhD thesis right here at the IWB in the field of laser welding. During the time at the end of my PhD thesis, we had a lot of projects together with BMW regarding contacting of cells by laser welding. It was a big topic in that time. It was around like 2010, I think, because they never did it before. Like they used screws and these things. And of course, like it ends up when you do these kind of projects, they ask you if you want to start working for them. So I ended up at BMW, responsible for the laser welding technology in the module and pack assembly of the i8. So it was kind of like, and the i3 had been the first projects to be industrialized for electromobility at BMW. And at the same time at BMW, they also started like a research group responsible for doing road mapping in the field of battery cells. And they had the task to investigate and better understand what are the next cell chemistries. And they started a network all over the world with research institutes and worked together with startup companies to get new technologies. And after 2 years of this project running, the battery project, they said, okay, they want to have kind of a prototype shop where they can actually test new cell chemistries in a given standardized cell geometry. And the cell geometry should be close to what we have had in the projects during that time. So it was a it was a prismatic cell design they wanted to have. And since I was working at the prototype shop in that time, I was had the fortune at the end that they asked me, do you know someone, would it be possible to do it at the prototype shop to build up like a first assembly line for that? And I said, of course, I would love to. And so I ended up together with one other colleague with like the first small battery assembly project at BMW. And we built up like a first dry room, first assembly equipment. And that was actually the starting point for me to get in deeper contact with battery cells. And ever since then, I stick to the topic. So we did like this project at BMW, then the Battery Cell Competence Center, then the Cell Manufacturing Competence Center, and so on. So it was an ongoing story. And it also gave me the opportunity to apply for the chair here at the IWB, because at the IWB and also at the Fraunhofer IGCV, for which I'm also responsible, during that time when I was in industry, they started a lot of battery activities. So it was actually quite a good match then to my background, which I was able at BMW to build up, and what the institutes did demand during that time.
Okay. Since you have so many roles, can you shine light on what your current positions are and how you contribute to our field?
Okay, I own the chair for production technology and energy storages at the Technical University of Munich. And this chair is embedded at the IWB. The IWB is a production technology institute. I am responsible for the IWB together with my colleague Christina Reuter and my other colleague Michael Zäh. So we run the institute together. We do not only take care about battery cells, but also about assembly technology, laser welding, machining, so everything which is relevant for production technology. At the same time, I'm responsible for Fraunhofer Institute, the Fraunhofer IGCV, which is also a production technology institute. So it's like if you regard like the institutes as a pipeline from basic research to application, that would be the second part of the pipeline. First part is production technology at the TUM. The second part is Fraunhofer production technology. And there I'm also responsible for the institute together with two colleagues, both also from the Technical University, Wolfram Volk and Klaus Drexler.
Okay. There's a lot of positions and a lot of work and
a lot of fun.
that's a good answer. Great. Yeah, and what I would like to understand from you is having this many roles and this overview over the topics like research, but also then into the direction of industrial application. Where do you see the current role of battery research in order to leverage our ability to think about realizing industrial production in Europe of battery cells?
I mean, the responsibility of research is also to create new ideas, to create innovations. We have what is probably special at the Technical University in Munich. We have what we call TUM Battery, which is kind of the alliance of all the chairs which are working in the field of batteries. So we have access to really groundbreaking new results in electrochemistry and chemistry. And here at the IWB, we are kind of the production hotspot where all these innovations then can come together. So we're building up right now, as you have seen probably in the lab, two new dry rooms. So at the end we will have like around 300 to 400 square meter dry room area, in which we will have state-of-the-art equipment for battery cell production, from powder to pouch cells. And we do this in classical lithium-ion battery, but also in solid-state battery technology. And actually, this has been very successful over the last 10 years, exactly because of the reason that we had been able to work very close together with natural sciences. And I think our responsibility is always to investigate new possibilities on material level and investigate if it's scalable, how it is scalable, how much does it cost to make it scalable.
Yes. So can we get a little bit technical on this?
Definitely.
So what are the matters at hand that you foresee to be scalable, especially in Europe?
You mean from a technical point of view?
Yeah.
Or from an economical point of view?
Let's talk about
the difference.
You're right. I would say let's talk about the technical part first, and then evaluate whether it's economically feasible.
Okay, what are the requirements to be, from a technical point of view, scalable? From my point of view, you have to be able to have a cell chemistry, or you have to have a cell chemistry which is processable in a way roll to roll at high speed. So from my point of view, that's the bottleneck. So every new cell chemistry, what we're doing, especially at the IWB, is to investigate, can we produce it roll to roll? Because this is like the standard way to produce it, and you have to at least get in this speed point, from a speed point of view, to produce the material in a cheap way, high quality, without a lot of scrap, and so on and so on. So first obstacle would be roll to roll level. So you have to bring the new material on something which is at least similar to roll level.
You're talking about electrode production right now.
That would be electrode production. The next step then, of course, is to keep the process chain running also for assembly at the back end. But that's the first step. So what we are doing very often is we get a new cell chemistry, very interesting from electrochemistry point of view, and then check, is it producible on the classical roll-to-roll level? And then get the bigger picture from a cost point of view. How much is the production system affected by this new material? But because very often we make the mistake that from a development point of view, we investigate like a material which is better for some reason, and we leave out the perspective of the producibility. And then it is very likely that you end up you have cheaper material, better material, but in production you get more costs and so on, so that the total cost of euro per kilowatt hour does not match.
Yeah. Are there any examples that you can name where you say like, hey, there's a really good scientific solution that's coming up, but it's from a material point of view, but it's not producible at the moment? Which
We had that over the last years with manganese-rich material. Had a lot of problems during that time regarding like gassing behavior and so on. And we did a lot of work together with the partners in there, and they managed to arrange it by coatings and so on to make the material really applicable at the end. So you have a very good, decent energy level and also okay price level. Very interesting things is also like solid state batteries, of course. They are, of course, a little bit further away down the road. But here we are right now at the moment, like bringing them on a roll-to-roll level. So we did a lot of work
all solid state.
With all solid state, yeah, sulfidic based all solid state batteries. So we did a lot of work together with the TUM Energy, which is like another activity within the TUM where we are kind of concentrating on solid state batteries very much. And we did a lot of research together with the cell chemistry professors at the Technical University of Munich. And we are right now on a level that we build up a dedicated equipment for roll-to-roll production of sulfidic based solid state batteries and trying to make that happen. Yeah. And right now it's the biggest topic is to investigate the cell assembly, how to build this kind of cells. But of course, I do not have to tell you there are still some technical obstacles and efforts you have to do to make this running, and it's still an open game from my point of view.
Yeah. To give a little overview of all the different tracks that we are researching on in Germany, Europe, but also globally, what are the technologies, first from a technical point of view, that you see feasible to be scalable, and at the same time also, of course, delivering performance advantages in comparison to the LFP NMC technologies that is currently available?
From my point of view, we are focusing very much on production technologies always. And I see this a little bit as problematic from my point of view.
Okay.
Because I think at the end of the day, the product is the game changer. Okay, so, and by the product, I'm talking about the cell design also. So we leave a lot the cell design outside of our discussion. So we're focusing on higher throughput, higher quality on a production level. But what is very interesting for me, from my point of view, is that the product, the cell itself, how you do the cell design, is directly influencing how you produce the cell and the other way around. So it does not necessarily make sense to improve one process without having a dedicated cell design in mind that you want to produce at the end.
Yeah, to make this more concrete, are you talking about the development of different prismatic cells, or like
everything,
long cells, like blade batteries, or increasing the diameter of cylindrical cells? So what are the product metrics that you say like these have to be understood first in order then to align the process to meet those product requirements?
So at the end of the day, I strongly believe that every product has like requirements for specialized cells. So we had like 10 years of discussion to make the cell a commodity. Yeah, in automotive industry, we discussed this, we tried that, never worked out, because we always want to have state-of-the-art products with the best performance possible, at least at a high-end level. Of course, you have a lot of applications where you have commodity cells, but I would say the area where the most added value is always the top edge. You want to be better than the other product. And then you always end up with like a special cell which fits exactly the requirements of your product. And we have to take everything in mind. So we do have to understand what is the specification of the product we want to produce. And then directly, how can we design the storage? And what is the best cell for this storage? Because I was very often in a project, you have like a black box, the cell, with good performance parameters, and you implement it into a storage and does not work together. Or you have a lot of efforts to make the cell working in that storage from safety point of view and so on.
Okay.
And from my point of view, we have to go to a level where we can do simultaneous engineering development of cell storage and product at the same time. It does not really make sense from my point of view if you're totally separating it. And so Of
So
course,
it
production
sounds like
technology
close
is
collaboration between research and industry.
definitely so. Production technology is super important to make it possible to realize new cell designs.
Mm-hmm.
Okay,
Mm-hmm.
and of course, it is important to get a higher throughput at the end of the day. But
Yes.
if we're thinking about the cost structure of a battery cell, production technology at the end, or the production of the cell, is not the major cost driver. Yeah?
Mm-hmm.
From my point of view, it's definitely material. So you have to optimize the cell, how it is working in the product, and of course, then it's scrap production and so on and so on. Production is super huge, important topic, but especially when you go into assembly, my experience was always you pick the right production process based on the cell design you want to have. Okay, so
Mm-hmm.
it's totally depending on that. Also from cost point, what tolerances do you need, and
Yeah.
so on. It has to fit together, so you cannot separate it.
Yeah, I think this builds a perfect bridge onto getting the other perspective from the economic point of view. And the critical question, will we design those products or not anymore? So the critical question, that will the European battery ecosystem exist with European battery cells and their cell designs, or will we maybe do research? But what I'm missing at the moment is the industrial adoption of our findings. So how do you see our role
It's the
in?
$1 billion question.
I know, but we need the statements of the leaders, because you have a good overview
Yeah.
to at least get us closer to finding an answer on that.
Actually, I have a very, very clear view on that topic because when I was still in this industry, I did a lot of work together with cost calculation guys because I realized it's very important if you want to improve a process, you have to really understand what is this leveraging on the cell level, like euro per kilogram level. When I started here at the IWB, we immediately started working on a big cost model to be able to make cost modeling of different battery cells and how is a production technology affecting like the cost of a battery cell and so on. And we published it last year. And based on this very big paper was a lot of work together with Braunschweig and also a colleague from the Technical University from the controlling chair. And based on this work, we did a big study in which we asked the question, what do we have to do to establish an ecosystem in Germany and Europe? We did this together with the CALIP, so it's a German network for battery cells. You most likely know them. And the first idea was we want to ask like the companies based on a case study. So we designed a case study. The case study was like, imagine in 5 years, we want to build up a 10 gigawatt hours battery cell production line. And we did like the bill of material, everything we need for that. How much of cathode material do we have to be delivered? How much separator, how much electrolyte, how much housings, how much equipment, at which time. So we did the whole calculation of the project. And based on that, we went to companies and gave them this requirement, this study, and asked them, okay, are you able to deliver it? What are your problems? Because the basic idea was they say, we cannot produce so much material, or we have this problem, we have not enough capacity to deliver it, because the basic idea was they are not able to do it. So what is very interesting from my point of view is that everyone said we are able to deliver it. So actually, the infrastructure and the ecosystem is ready at the moment. So what we did then is we had a closer look in.
So which year was that? Just
this year.
This was this year.
It's
so you say this year we are ready.
We would be ready to deliver everything we need for a 10 gigawatt hour production line.
Okay.
From technical point of view, but it's a big difference if it's from economical point of view.
Yeah. So can you pinpoint if the technical puzzle works out? What are we missing on the economic side, and by how far are we off?
So we have, first thing we have to understand and clearly to accept. Right now, we are in very troubling times in terms of transformation of the world. What is happening? We have a lot of crisis on the world, but at the same time in the background, we have the fight for added value, in which society it will take place to produce products which are relevant for the future. Because of do we have this high level of prosperity in Europe? Because we had been able to produce over the last 50, 60 years high level products, high added value in Europe by cars and so on.
Yes.
And this is the foundation of our prosperity in Europe. And what is happening right now is that everyone understood that battery technology is a huge topic in the future. I mean, we see the numbers.
If everyone understood, I think we would not have a problem right now. Or
Everyone on the world understood. And what is happening, you have a lot of overcapacities in Asia.
yeah,
You have like Inflation Reduction Act from the United States, where you also have like a lot of money to build up this industry. And if we
Yes.
make cost modeling again, we simply take like the benefits when you produce a battery cell in the United States, and take like a reference price. Let's say it's 100 euro per kilowatt hour, and you apply the cost reduction you have by tax benefits in the United States, you come out like 56 euros, something like that. You have to pay when you produce in the United States, or you have to pay when you produce it in Germany or in Europe, based on economical circumstances. So what we have to understand that in the next, from my point of view, 5 to 10 years, it will not be able to establish a production in Europe under normal economical
Boundaries.
requirements, boundaries, because we have the situation, I always call it a run for the market.
Yeah.
They try to buy this market. Okay, Asia is buying this
Yeah.
market by huge investments, and America is buying this market by huge investments.
Mhm.
And what I'm missing is like a common strategy in Europe. What is our approach to secure this market? But what is, from my point, not very helpful is if we try to build up cell production lines, and at the end of the day, we are asking ourselves, oh, it doesn't work. Because we are too expensive. Of course, we are too expensive. The other guys are trying to buy the market. So
Yes.
it's a question, if we believe this is a core technology, and I think we do this, okay? In Europe, we do believe it's a core technology.
Yes.
We have to ask ourselves, how can we establish an ecosystem which is big enough to survive, but we have totally to be aware of it will cost us something. Because from my point of view, we need to have this smallest possible ecosystem, which allows us to bring also new innovations into the market. Because what we are missing right now, and this was also very clear answer from the OEMs, we also did interviews with cell producers or product owners,
Okay.
and they said they do not want to.
So European cell producers.
Yeah.
Okay.
We do not want to do this together with probably a European producer, equipment supplier or material supplier, because they do not have enough experience from their point of view. Because we're talking about projects, billion-euro projects, and every risk you can reduce, you reduce it. And if you have a supplier who has never done it before, that's a big risk. I can totally understand that these people say, hey, it's more expensive and it's a bigger risk. Of course, they do not directly jump onto the topic.
Yeah, but let's focus on like how can we solve this puzzle? Because as you said, we have the technological competence, and this is what I saw back then at eLab at RWTH when I did my research and project work there. And this is what I see on the battery expedition campaign, visiting all those companies. We have huge potential out there, and people are motivated, and companies are also willing to change and make the transition. Right? It's really what I think. A change in mindset is possible, and a change of people is not necessarily needed, because many people of our field understood that something has to happen. But the question is how, and how can we build a first success story? Building you mentioned 10 gigawatt line, some pilot giga line that really shows off. Okay, this is by the real European participants, machine builders, etc., etc.
Exactly.
Some role model that we then can take and copy and paste with our own European identity, being sustainable, being energy efficient, being fair, due diligence policy, like also considering the material side. But what from your perspective are, in brief, are the next steps that you would suggest on doing?
So in brief is always a difficult question for a professor.
I know.
So for the first thing is we have to be aware of the market volume in Europe is big enough to establish an ecosystem. Okay, so we also investigated and we asked the question: how big has the business? How big has the business to be, from my money point of view, for like an equipment supplier or material supplier to make it sustainable for this company? So
Yes.
we answered that, and we did investigate from how many companies is space in the European ecosystem to deliver. And the next question is how much money you want to spend, from my point of view, because we have I think the most important thing is to look us in the eyes and tell us the truth. It is a run for the market right now, and it will not happen unless we want it to be. And I see a chance in there that we have a lot of strategical relevant needs for battery storages in different fields. And I think it needs a joint political and industrial will to pick one of these needs, where we say, for example, okay, we do not want to have in that field products from Asia. I'm Swabian, so if someone offers me something which is lower than the material price,
Of course, you take it.
why shouldn't we buy it? It makes sense. It's good. But at the same time, we have to think about how can we stay in that market? How can we keep the competency to grow out into that market in different fields additionally? So my advice would be, and this is what I'm repeating again with a lot of people right now, because I think it's the right time to have this discussion, because from my point of view, I think during the next 4 years, we can do something. We have to align every our activities on a strategical relevant topic from a product point of view, where we need a product. And then we should try to align also our research activities, and really supported by politics to build up like a closed production chain, European production chain for these products, which we want to have safe in our field. And we have to have the discussion, what is it's also a question, the cheaper the better. So we have to discuss how big does the ecosystem have to be
in order to be cheap.
Not only in order to be cheap, it should be as cheap as possible. But of course, if it's too small, then it's probably not fulfilling its purpose anymore.
Then you don't have
how big does it have to be? And then we have to have the discussion, is it worth for us to pay this money or not? And it's very interesting if you investigate the treaty in the new government, or the plan, what they want to do. They have very, very often is the word written in there, which is called in German the anchor customer, anchor Kunden. And that's exactly, I think, from my point of view, in which direction it could be. Like you have, from a governmental point of view, you have the need, a strategical need for a battery cell in whatever field, like for safe energy storage or military purposes or anything else, and then try to address this need and try to align all the activities on that topic, because I think it's a good point in time. We have everything we need. We have the people. We still have the companies. It's critical right now because they are all in trouble at the moment. So we have to bring these things together to get something as a society out of it. And I think what we need to have is like the competency and to have access to this core technology, because it will be defining all the products in the future.
Yeah, and we need to combine those different competences, core technologies, but also competences. And we're not talking only about technology. You mentioned the political stakeholders. We're talking to financial stakeholders, investors that believe in this European ecosystem. But still the question is how, and as we also talked about earlier, technologically I think we don't have a critical problem, but where we have a critical problem is bringing this potential on track. And this is why I came up with this communication format, in order to allow a deeper, more granular exchange about the matter at hand, but also the potential solutions that are on the horizon. So on this expedition, I ask every guest in this format the three same questions to get a repetitive perspective from many different angles. And the first question is, in brief now, because this has to be really short. From your perspective, Professor Daub, what is the biggest challenge, or what are the biggest challenges, if you want to name 2 or 3 bullets, that are hindering us on building the European battery ecosystem?
Aligning our possibilities.
Okay.
On one particular target.
That was on spot. What is the biggest potential? So where do we as Europeans shine? Where do we have potentially a market advantage?
Let me rephrase the question. I do not think everyone has the same possibilities, but when we manage to establish experience by establishing an ecosystem, then we have always the possibility to enter into the market in different fields, material, equipment, and so on, also the big market. So I think we have everything we need to have access to this very important market for the future. And what can be our probably benefit is the way we are working together between research and industry to implement new technologies, new materials quickly into the market. But we don't have to fool ourselves. I mean, the others are also very fast. The others are also very brilliant. So it's like it's a competition at the end of the day, and we simply have to do it. Then we also have a chance.
Okay, sounds like we have to have discipline and work.
Probably.
Good.
It's always a good thing to have.
Yeah, but I think that this is how I would summarize this. Really using what we have, but using it because it's competition right now.
I mean, the others also don't do miracles, It's like hard work and bring technology into the field. And of course, they have a very strong political will right now.
Yeah. So final question. If you have one advice that you would give our industry, what would it be?
For industry or for politics?
Well, you can also do it for politics, for the stakeholders in our field.
Let's identify strategical relevant areas and build up an ecosystem in that field.
Okay.
And don't try to be like the biggest player in the market right now, because we are not. And we should find the way to make it smart without spending the less money we spend to establish ourselves in that field, to stay in the game. The better it is right now, from my point of view. So the topic must be right now staying in the game and not winning the game, because I'm pretty sure that in the future things will change and there will be new possibilities then.
That's a realistic and honest statement. Being aware that unlike the automotive industry, we will not be the biggest in this field, but we will participate with our competence.
Exactly.
Close that out. Thank you very much for this conversation.
Welcome. Thank you very much for your interest.